Hello everyone, I am Teacher Michelle and welcome to another episode of Unang Math. In this episode, I will be discussing this lesson about the conditions for similarity of triangles. In our previous episode, we already studied similar figures or similarity in figures, including its properties. Okay, this time, how about if it's not mentioned in the given or problem that the two figures are similar? So how are we going to find out if the two figures are similar? Okay, this is now the reason why do we need to study and understand the different conditions for similarity, specifically similarity of triangles. Okay, let's start with this first condition. When the ratios of the length of the three pairs of corresponding sides are equal, then the two triangles are similar figures. Okay, if we are just talking about the length of the three pairs of corresponding sides are equal, then that's SSS congruence. Okay, since we are including the ratios of the length of the three pairs of corresponding sides, which are equal, then that's now SSS similarity. Okay, what does it mean by this one? Let me explain using these two triangles. Okay, we have this smaller triangle and this bigger triangle. So as you can see, this side AB corresponds to this side A prime, B prime, as indicated because they are similar colors. So this side BC corresponds to this side B prime, C prime. And we have here CA or AC corresponds to this side C prime, A prime. So in this first condition, when the ratios of the length of the three pairs of corresponding sides are equal or constant, then those two triangles are similar figures. So it means get the measure of this side. Let's say, for example, this side corresponds to this side. Get the measure. The ratio must be the same ratio with these corresponding sides and these corresponding sides. So the ratios of the length of the three pairs of corresponding sides are equal or constant. Okay, let's give specific example. Okay, we have here two triangles. We actually don't know yet if these two triangles are similar figures. So let's find out or let's prove if these two triangles are similar figures. Okay, the first thing we need to do is name these triangles. Okay, in this triangle, let's name this as triangle A, B, C. So this is triangle A, B, C. Okay, how about this triangle? We have to be careful because we need to consider the corresponding points or the corresponding sides. Okay, how are we going to do that? Okay, if this is triangle ABC, this side AB, as indicated here, it's 9 centimeters. This side AC is 15 centimeters. So it means this side AB is shorter than this side AC. Okay, now let's take a look at this triangle. Okay, this side DE, which is 6 centimeters, is smaller or shorter than this side DF, which is 10 centimeters. So it means D or point D corresponds to point A. So we have here triangle DEF. Okay, again, if we will check, this is 10 centimeters, longer than 6 centimeters, corresponds to this side AC, which is also longer than this side AB. So we have triangle ABC, triangle DEF. Okay, now let's find out if the ratios of the length of the corresponding sides are equal or constant. Okay, first, this side AB, which corresponds to this side DE. So AB, DE. AB is 9 centimeters. DE is 6 centimeters. So we have here 9 is to 6. And if we will simplify, this is now 3 is to 2. So the ratio of these corresponding sides is 3 is to 2. Okay, now, what about these corresponding sides? A, C, and D, E. So we have here A, C, and this is D, E. 15, and this is 10. So 15 is to 10. And if we will simplify, this is also 3 is to 2. Same with this first ratio that we got. Okay, next one would be side BC. This corresponds to EF. BC is 18 and EF is 12 centimeters. So 18 is to 12. And if we will simplify, we will be dividing both numbers by 6. So it's 3 is to 2. So as you can see, okay, the ratios of the length of the three corresponding sides are equal or constants. It means these two triangles are similar figures. Okay, now let's move on to the second condition. Okay, according to this, when the ratios of the length of the two pairs of corresponding sides are equal and the included angle is equal, then the two triangles are similar figures. Okay, if we are just talking about the length of the two pairs of corresponding sides are equal and the included angle, that is SAS congruence. And again, since we are talking about the ratios of the length of the two pairs of corresponding sides that are equal and the included angle is also equal, then that's SAS similarity. Okay, what does it mean by this second condition? We have here these two triangles. This side AB in this triangle corresponds to this side A prime, B prime in this triangle. Okay, this side BC corresponds to this side B prime, C prime. And this angle B corresponds to this angle B prime in this triangle. And these are equal in measures. Equal in length, equal in length. So side, angle, side. So we have SAS similarity. Okay, for you to understand better this second condition, let's give specific example. Okay, let's find out if these two triangles are similar figures. Okay, again, the first thing we need to do is we have to name these triangles. First, let's name this triangle A, B, C. Okay, what about this triangle? Okay, again, we have to consider the corresponding sides or the corresponding points or angles. Okay, since we have to consider here the included angle, okay, in this figure or in this triangle, this angle B is 30 degrees. Okay, what about here? We can also see 30-degree angle in this triangle, and that is angle F. So, if we will consider this side, this is 3 centimeters, and this side is 4.5 centimeters. So this is shorter and this is longer. Okay, take a look at this triangle. This side is 2 centimeters and this is 3 centimeters. So it means this side is shorter than this side. So it means FE, or this side, corresponds to this side BA. So we now have triangle ABC. So this is now triangle EF. So AB corresponds to EF. So this is triangle EFD. So FD corresponds now to BC. Okay. ABBC. Okay, and then DA corresponds to CA. Okay, now let's find out if the ratios of the two corresponding sides are equal. Okay, we already know that these two angles are equal. So let's find out the ratios of the two corresponding, or the ratios of the length of the two corresponding sides. If they're equal, then it means these two triangles are similar figures. Okay, let's start with this side AB. This is 3 centimeters. What about EF? 2 centimeters. So it means 3 is to 2. Okay, what about this side BC? This is 4.5 centimeters. Okay, this corresponds to FD, which is 3 centimeters. So 4.5 is to 3. And if we will simplify, we will be dividing both numbers by 1.5. So this is now 3 is to 2. So we have same or equal ratios of the length of the two corresponding sides. So the ratios of the two, or the ratios of the length of the two corresponding sides are equal, and the included angles are also equal in measures, then that means these two triangles are similar figures. Okay, now for the third and last condition, according to this, when two pairs of corresponding angles are equal, then those two triangles are similar figures. Okay, what does it mean by this one? This is also what we call AA similarity. So in these two triangles, this angle that corresponds to this angle are equal in measure. This angle that corresponds to this angle also equal in measures. So we have here two pairs of corresponding angles that are equal, then these two triangles are similar figures. Okay, let's give specific example. So let's find out if these two triangles are similar figures. So let's name this triangle ABC. So we have here triangle ABC. Okay, this angle B is 75 degrees. What about here? We cannot find 75-degree angle here. But this angle C is 60 degrees. We have 60 degrees in this triangle, and that's angle E. So if this is angle or triangle ABC, then it means this is now, okay, we have here triangle, okay, FDE. So F here, or angle F, corresponds to angle A. So this is also 45 degrees. And angle D corresponds to this angle B. So this is also 75 degrees. So angle C is angle E, which is 60 degrees. So when you see a triangle or triangles that have two corresponding angles that are equal in measures, then those two triangles are similar figures. Okay, now let's answer this problem to check whether we understand all those conditions. Okay, the question is, which of the following conditions doesn't make triangle ABC similar to triangle DEF? So, these are the two triangles. So, we are looking for the condition that doesn't make these two triangles similar. Okay, the first condition according to this is segment AB or side AB, this side is to side DE. Okay, this is equal to BC, EF. And AC, or this side, is to DF. So AB, DE, BC, EF, AC, DF. So this is actually SSS similarity. So this is correct. So this condition makes these two triangles similar figures. Okay, what about the second condition? We have here AB, so this side, DE. And AC, or this side, is to DF. DF. Okay, now, angle A is equal to angle D. So, this is S, or side, angle, side. So, SAS similarity. So, it means these two triangles are similar figures. So, this is also correct. Okay, for number 3, according to this, BC, or this side, is to EF. AC, or this side, is to DF. And angle C, or this angle, is equal to angle F. So we have here side, angle, side. So this is also SAS similarity. So this is a correct condition for these two triangles to be similar figures. Okay, what about number 4? For number 4, AB, or this side, is to DE. BC, or this side, is to EF. And then angle B, or this angle, is equal to angle F. Okay, this is not correct. For these two triangles to be similar figures, then the angle should be, for this triangle, it should be this angle E and not angle F. That's why number 4 is incorrect. Okay, what about for the last option, angle B? Okay, this angle is equal to angle E. Angle C is equal to angle F. So, the length, or the rate, they call this one the measures of two corresponding angles. Two pairs of corresponding angles are equal in measures. Then these two triangles are similar figures. So, this is also correct condition. So, the answer to this question is number 4. Okay, for the next episode, we will be solving more problems and questions related to this topic.